Hey everyone, today we will discuss a problem statement asteroid collision. This is a very common problem statement and it is asked in many different companies like Amazon and Microsoft. So we'll go through the problem statement. It is given that we are given an array of asteroids of integer representing asteroids in a row. So this is our sample input. These are 5, 10 and minus 5. The indices of the asteroid represents in the array in the relative position in space. It means that 3 asteroids 5, 10 and minus 5. So the array index represents their relative position. So it means 5 is here, 10 is here, and minus 5 is there. Now for each asteroid, the absolute value represents its size. So their absolute value represents their size, and sign represents the direction. Positive meaning right, and negative meaning left. And each asteroids move at the same speed. Okay, find out the state of the asteroids after all collisions. If two asteroids meet, the smaller one will explode, and if both are of same size, both will explode. Two asteroids moving in the same direction will never meet, of course, because they are of same speeds. Now let's analyze the problem statement. So we have this 3 asteroids. Now in this one, so 5 and 10 will not collide. 10 and minus 5 will collide, and since minus 5 is smaller in magnitude, it will get destroyed. So 5 and 10 will be here, and since both are of same direction, they'll never collide. So this will be the resultant array. Now let's take another input. Let's suppose we have 5, 10 and minus 15. Now they both are going in right direction, minus 15 is in left direction. So first we'll check 5 and 10, yes, no collision. 10 and minus 15, yes, there will be a collision, but 10 will be removed. So I'll just erase, minus 15 will be there, and 5. Now there can be multiple collisions as well, or this will remain as it is. So 5 and minus 15 will collide, and 5 will get destroyed. So minus 15 will remain. So if we think about the approach, what we are seeing is that let's suppose this is our array. Now let's assume this is one of the array, and we add minus 12, or let's suppose minus 16 to this one. Now what will happen? We have to see that what will happen to the array once we add one more asteroid. This is minus 16. So in this case, first we'll have to check the 15 with minus 16. Yes, so 15 will get destroyed, minus 16 will remain. Then minus 16 with this 10, so 10 will get destroyed, minus 5 will be there. Then we'll check minus 5, minus 16. They will not collide because both are of same direction, so they are moving both in left direction. So the R minus 16 will be this. This is our stable array. So what we can do is we can use a stack. Now let's take this example again. Minus 5, 10, 15, minus 16. Okay, initially the stack will be empty, so we'll just add minus 5 to it. Like we are starting with the array. The next is 10. We'll compare 10 with the stack top. Stack top is minus 5 and 10. Will they collide? No, because minus 5 is going left and 10 is going right, so they'll not collide. So we'll just add that to the stack. Right, now next is 15. So whether 15 and 10 collide? No. So we'll again add this to our stack. Minus 16, yes, it will collide with the stack top. So we'll remove the one which will get destroyed. So in this case 15 will get destroyed. So it will be 10 and minus 5. Now we'll check minus 16 with 10. Yes, 10 will again get destroyed. So minus 5 will be there. We'll check minus 16 with 5. Yes, minus 5 will not collide with minus 16. So we'll just add this to our stack. Now let's suppose there were 2 more elements to the input array. Let's suppose there were like 20 and minus 10. So then we'll iterate to this one. 20 will check with minus 16. It will not collide, so we'll add 20 to the stack. Minus 10, yes, it will collide with 20, but in this case minus 10 will get destroyed because it is smaller in magnitude, so the stack will remain as it is. And finally this will be our resultant asteroids. We'll pop it from the stack and reverse it, so we will have the final asteroids as minus 5, minus 16 and 20, and that's how we can solve this problem. Now if we talk about the space and time complexity, so time complexity is, so we are traversing the array once, and for each element what are we doing? We are either pushing that to a stack or we are popping. So at most 2 operations on an element, so it will be 2n, which makes us the time complexity as O of n only. Space complexity, so we are using an extra space. We are using a stack to store the elements, so it will take O of n as the extra space. So this will be the approach to solve this problem, and now we will move on to the coding part. So that's the code for our the approach that we discussed. We have taken this asteroid collision function. We have taken a stack. We are iterating over the elements in the given array. We have kept a variable destroyed, which is of type boolean. Now if the stack is not empty and asteroid is less than 0 and stack.peak is greater than 0, so it means this is our collision condition. In this case we will check the magnitude and accordingly we are destroying. Now this destroyed flag is set for the one for which the current asteroid will get destroyed, and if it is not destroyed at the end of the loop, it will be pushed into the stack, and finally the results is stored into the result array by popping the stack, and it is returned. If I just run this function, so it will give me the output as 5 and 10, and if I change the input array as 5, 10 and minus 15, it will give me minus 15. So this is the solution for the asteroid collision. Hope you like the video. If you do, please like the button and subscribe to the channel. Going forward, I'll make more such videos on different problem statements. Thank you for watching. See you next time.